Compound interest is the interest added to the principal amount. Thereafter, earns interest. Or in other words, this is the interest on top of interest. So to further understand why or what do we mean by interest of top of interest, when you have a principal, it earns an interest for the first period. And the principal plus the interest of the first period will be your future amount. After that, first period, for the second period, your present amount will be the accumulated amount of your present and your interest. Thereafter, it will earn another interest. So to explain it clearly, let's make a table. So we have your n, or the number of period. We have your p, or the principal. We have I for interest, and we have F for the future, given by the formula F equals P plus I. So at the first period, the value of your principal is P, while your interest is your principal multiplied by the interest rate. So that is the interest earned. Now, the future amount is the principal and the interest. So the accumulation F is P plus PI. So P plus the interest. So it can be simplified by factoring out P equal to, so it will be equal to P times the quantity of 1 plus I. Now for the second period, so you will use the future amount of first period as your present amount here. So the principal of P times 1 plus I. And the interest is given by your principal for the second period of P times 1 plus I multiplied by the interest rate. So it will become P times 1 plus I plus P times 1 plus I multiplied by I. So we can factor out the same figure, P times 1 plus I, so it becomes P times 1 plus I. So copy this, multiplied by 1. So what will remain here is 1. Will remain here is I, 1 plus I. So this can be written as P times 1 plus I squared. Now for the third period, so your P here will be this, the computed future amount for the second period, P times 1 plus I squared. So your interest is P times 1 plus I squared multiplied by I. So adding the two, we have F of P times 1 plus I squared plus P times, so this will be P times 1 plus I squared times I. So to further simplify, we can factor out P times 1 plus I squared, and this will become P times 1 plus I squared times 1 plus I. Further simplifying, we have p times 1 plus I cube. So, if you notice the trend, the formula for as the period increases, the future amount increases, and the formula for the first period for f, we have p times 1 plus I. So this is raised to 1. For the second period, we have f equals p times 1 plus I squared. For the third period, we have f equals p times 1 plus I cube, until it reaches the end period wherein we'll be having f equals p times 1 plus I raised to n. So from this, we can therefore conclude that the formula for f is equal to p times 1 plus I raised to n. And the formula of p, if you divide the equation by 1 plus I raised to n, so p is equal to f over 1 plus I raised to n. So these are the two formulas. Now we have f as the future worth, we have p as the principal, or the present worth, we have I is the rate of interest per interest period. We have n equals the number of interest period. So here, I is not just the nominal rate. So the interest period varies. That's why we have I equals the nominal rate of interest over M, where R equals nominal rate of interest, and M is the number of compounding periods per year. So what do we mean by number of compounding periods? When we say compounding periods, that is the number of times the interest being compounded. So it can be either compounded annually, semi-annually. We also have quarterly, bi-monthly. We also have monthly. So annually, one compounding per year. Semi-annually, we have 2 compoundings a year. For quarterly, we have 4 compounding per year. So this compounded every 3 months. Bi-monthly, so this is every 2 months, so we have 6 compounding per year. Then monthly is every month, so we have 12 compounding periods per year. Then we have n is equal to my. So m is the number of compounding periods and y is the number of years. So this is a little reduced compared to simple interest. Now we also have to define the effective rate of interest. So effective rate of interest is the actual rate of interest for principal value in a year. So this is defined by the formula for the effective rate. We have 1 plus I raised to m minus 1, or 1 plus r over m raised to m minus 1. So we have something to remember, that for 2 or more nominal rates to be equivalent, their corresponding effective rates must be equal. Example, if we convert quarterly to monthly, so we equate their effective rates. For example, we have convert %12 compounded monthly to quarterly. Now we have to equate their effective rates in order to get the nominal rate. So for quarterly, we have the effective rate of 1 plus the nominal rate divided by m of 4 raised to m minus 1 is equal to, for monthly, so this is equal to 1 plus 12% over 12 raised to 12 minus 1. Now your nominal rate of interest would be equal to, so we can cancel this amount and this for easier calculation. So we have 1 plus your value of the nominal rate over 4 raised to 4 equals 1 plus 12% over 12 raised to 12. So if we try to solve, we have the nominal rate of 0.1212 or 12%. Therefore, the equivalent quarterly nominal rate from compounding 12% monthly is 12.12%. So that wraps the concept of compound interest.